Have you ever really thought about how that movie you're streaming or that text message you just sent literally flies through the air? I mean, it feels like actual magic, right? But it's not. It's a secret language, a language spoken by waves. And today, we are going to decode that language and find out exactly how your Wi-Fi speaks. So this is the big question, isn't it? Everything in our digital lives, every photo, every email, every single song is really just a long, long string of ones and zeros. So how in the world does that stream of bits get from a router over to your device with no wires attached? Well, that's exactly what we're about to break down. All right, here's our game plan. We're going to start with the basic idea, the secret language of waves. Then we'll look at some super simple signals using analogies that you'll get in a heartbeat. After that, we'll get into a much more clever twist. And finally, we'll uncover the ultimate high-speed signal that powers pretty much everything we do today. Okay, so the main idea here is something called modulation. Now, that sounds technical, but just think of it like a translator. Its job is to take the digital language, the ones and zeros, and encode it onto an invisible carrier wave. Like the radio waves your router pumps out, so it can actually travel through the air. It's really this crucial four-step journey. First, you've got the bit stream coming from your computer. Then a modulator, which is basically the coder, changes a wave to represent those bits. That wave then travels through the channel, that's the air, and gets picked up by a demodulator, which acts as the decoder, turning all those wave changes right back into the original ones and zeros. See? Simple enough. To really get a handle on this, let's start with the very first words of this wave language. We're going to use some dead simple analogies with light and sound to understand the most basic ways to do this. Okay, just imagine you're trying to send a message to your friend across a dark field, and all you have is a flashlight. You could agree on a simple code, right? Flashlight on means 1 and flashlight off means 0. Just by doing that, you're sending digital data. You're modulating. So that flashlight trick, it actually has a technical name, amplitude shift keying, or ASK for short. Amplitude is just a fancy word for the strength of the wave. So a 1 is a high-strength wave, and a 0 is a low-strength wave. It's super simple to do, but just like a dim flashlight on a foggy night, it gets messed up really easily by noise and interference. So the flashlight method is a little shaky. What if, instead, you used a whistle? You could agree that a high-pitched sound means 1, and a low-pitched sound means 0. Now that's a lot harder to get wrong, even if there's a little background noise, right? And this perfectly describes frequency shift keying, or FSK. Instead of changing the wave's strength, we're now changing its frequency, its pitch. This makes it way more resistant to noise than the flashlight method. The only catch is that it needs a little more room on the airwaves, more bandwidth, to pull it off. All right, now we're going to get a little more clever. We've talked about changing a wave's strength and its pitch, but what if we could change something else, something a bit more subtle? Let's dive into the power of phase. To wrap your head around phase, picture a carousel. It's spinning at a totally constant speed. Let's say that at any given moment, if a horse is facing forward, we'll call that a 0. But if we could instantly flip that horse so it's facing backward, we'll call that a 1. See? The speed didn't change, the height didn't change, just its orientation, its starting position. That's its phase. This is exactly what phase shift keying, or PSK, is. We're not touching the amplitude or the frequency of the wave, just its phase. A 0 could be the wave just doing its normal thing, while a 1 is represented by instantly flipping the wave's cycle. That's a 180-degree shift. And let me tell you, this is a huge leap forward. It gives us a much higher data rate, and it's way more efficient with our precious bandwidth. So we've covered strength, pitch, and orientation. What's left? Well, what happens if we combine these ideas? This is where we get to the absolute master stroke, the technique that makes the crazy internet speeds we use every single day possible. It really is as simple and as powerful as this little equation. We take the idea of changing the amplitude, our flashlight, and we combine it with changing the phase, our carousel. The result is an incredibly powerful technique called QAM. Quadrature Amplitude Modulation. QAM for short, is basically doing two things at once. It can create a wave that is not only high strength, but also facing backward, or maybe low strength and facing forward. By combining multiple levels of amplitude with multiple phase shifts, you can suddenly pack a ton more information into the exact same signal. And this is why QAM is the king of modern communication. It gives us ridiculously high data rates, it's super efficient with bandwidth, and it's also extremely resistant to noise. And this isn't some abstract idea. This is the actual language being spoken by your Wi-Fi router, by 4G and 5G cell towers, and even by digital TV broadcasts. It's everywhere. But of course, there's no free lunch. As we've just seen, every step up in performance required a more sophisticated trick. QAM is insanely efficient, but it also needs much more complex and precise electronics to both create the signal and to decode it correctly on the other end. You know, this table really sums up our entire journey perfectly. We started with ASK, simple, yeah, but with pretty low noise immunity. We moved up to FSK, which was better. Then PSK gave us high immunity with just moderate complexity. And finally, there's QAM, changing both amplitude and phase, giving us that very high noise immunity, but as you can see, it's also the most complex. You can literally see the evolution right here. So let's just do a quick recap. The big takeaway is that modulation is the art of turning digital ones and zeros into physical changes in a wave. We saw how these techniques build on each other, from a simple on-off flashlight pulse all the way to these sophisticated combinations. And most importantly, it's QAM, the combo of amplitude and phase, that really unlocks the high-speed wireless world we all live and breathe in. So the next time your phone connects to Wi-Fi and that video starts streaming instantly, you'll know what's really going on. It's not magic. It's an incredibly fast, incredibly complex conversation happening through the air, a secret language of waves, with your device speaking fluent QAM.